If the idea that Tornado Alley is no longer where the maps say it is, that the most dangerous place in America for a killer storm is now a forested ridge in Tennessee or a mobile home park in Mississippi, has you as riveted as it has me, make sure to hit like and subscribe to Signal Watch so you don't miss a single update as this story unfolds. Drop a comment below and tell me where you're watching from, what time it is there, and this. Does your home have a basement or a storm shelter? Because where you live may matter more than you think. If you want to help this community grow, share this video on X, Facebook, Reddit, or even just in your group chats. You're the reason we can keep chasing stories like this. So thank you for having our back. Now, a documented 140-mile eastward migration of the atmospheric boundary that feeds tornado formation. A shift measured in Columbia University data going back to 1880. A 2024 study finding that Mid-South housing exposure to tornado disaster has tripled since 1980. The largest tornado outbreak ever recorded in the month of March. 118 tornadoes, $11 billion in damage, and a pattern that the researchers who study it say is becoming the new normal. And a warning, infrastructure built for open plains radar sightlines now facing rain-wrapped, nighttime tornadoes in forested terrain, while some of the offices serving the most at-risk counties lost their permanent overnight forecasters. Now, settle in and let's get into it. March 7th, 2025, 8 days before the first tornado touches down. The Storm Prediction Center in Norman, Oklahoma, the nerve center of the nation's severe weather forecasting apparatus, begins monitoring a developing atmospheric pattern. The signals are there, buried in the model runs, a vigorous trough ejecting across the high plains, moisture surging northward from the Gulf of Mexico, wind shear values climbing into territory that forecasters have learned to respect. 8 days out. And what they're watching isn't a threat aimed at the flat, open grasslands of Kansas or the red clay hills of central Oklahoma. It is aimed with the precision of a changed atmosphere at Missouri, Arkansas, Mississippi, Alabama, Tennessee. By March 13th, the Storm Prediction Center had enough confidence to issue a moderate risk designation for severe weather across portions of the Midwest and Deep South. By the afternoon of March 14th, that risk had been upgraded and upgraded again. By the time the final outbreak statistics were compiled, the numbers were staggering in a way that went beyond any single season's data. 118 confirmed tornadoes. That's the final count, certified by the National Weather Service through painstaking post-event damage surveys. 118 tornadoes in 4 days, March 13th through 16th, 2025, making it the largest tornado outbreak ever recorded in the month of March. Not in a bad year, not in a year with unusual atmospheric setup, the largest ever, in the month that by the public mythology of severe weather isn't supposed to be peak tornado season. 44 people were killed. 23 of those deaths were directly tornadic. 10 in Missouri, 7 in Mississippi, 3 each in Arkansas and Alabama. The remaining 21 came from the broader storm system, straight-line winds, flooding, secondary impacts. The financial toll came in at $11 billion, unadjusted for inflation. That figure is not a rounding error in a season of bad storms. It is the highest damage total ever recorded from a single tornado outbreak in American history. And the outbreak intensity score, the standardized metric the atmospheric science community uses to compare outbreak severity, came in at 147. The classification at that score, historic. What the numbers don't capture is where these tornadoes went. Because if you overlaid the damage paths from March 13th through 16th onto the map that most Americans carry in their heads when they picture tornado country, the mental image built from a generation of storm-chasing documentaries, from The Wizard of Oz, from Twister, from every news package filmed against a backdrop of Oklahoma wheat fields and Kansas grain elevators, you would find almost no overlap. The storms concentrated across the lower Mississippi Valley and Deep South. An EF4 tornado in Diaz, Arkansas, with measured winds of 190 miles per hour, not Oklahoma, not Kansas, Arkansas. A second EF4 tornado, carving a path of nearly 94 miles across the Ozarks, became the third longest recorded tornado track in Arkansas history. An EF3 killed 3 people in Poplar Bluff, Missouri, after ripping through a trailer park just after midnight. An EF3 struck Tylertown, Mississippi. An EF3 hit Plantersville, Alabama. An EF4 tracked from Kentwood, Louisiana, 45 miles northeast, into Darbin, Mississippi. The Storm Prediction Center, in the days before this outbreak, had issued what's called a Day 2 high risk, a level 5 of 5 severe weather designation issued not for the day immediately ahead, but for the following day. It was only the 3rd time in the era of modern forecasting that a Day 2 high risk had been issued for the Deep South. The previous 2 occasions were April 7th, 2006 and April 14th, 2012. The forecasters weren't surprised. They'd been watching the atmosphere build for over a week. What they were watching was not an anomaly. Here is what this investigation is built around. The March 2025 outbreak was not a random clustering of unfortunate events. It was the latest and most dramatic confirmation of a shift that a growing body of peer-reviewed research had been documenting for years. The tornado corridor, the atmospheric zone where the ingredients for violent, long-track tornadoes most reliably converge, has been moving. Not metaphorically, physically, measurably, eastward, into a region that is more populated, more forested, more reliant on vulnerable housing, and less psychologically prepared than the region the storms are leaving behind. The question this investigation will answer is not whether that shift is happening. The research on that point has reached something close to scientific consensus. The question is what the shift means. For the families sleeping in manufactured homes in western Tennessee at 2 a.m, for the National Weather Service offices now serving the emerging front lines of American tornado risk with budgets and staffing built for a different geography, and for a country whose mental map of where tornadoes go is at least a decade behind where the tornadoes are actually going. October 17, 2018. Victor Gensini, a professor of atmospheric sciences at Northern Illinois University in DeKalb, Illinois, publishes a paper in the journal NPJ Climate and Atmospheric Science alongside Harold Brooks of NOAA's National Severe Storms Laboratory in Norman, Oklahoma. The paper's title is Measured and Academic. Its findings are not. Gensini and Brooks examined tornado frequency trends across the contiguous United States from 1979 to 2017, nearly 4 decades of data. They used 2 entirely separate analytical approaches. The first tracked actual tornado reports during that period. The second used the significant tornado parameter, a meteorological index that measures the simultaneous presence of atmospheric conditions favorable for tornado development, independent of whether anyone actually observed a tornado. The STP approach was specifically designed to control for one of the most persistent problems in tornado climatology, the fact that more people in more places means more tornadoes get reported and confirmed than in an earlier era of sparse population and limited spotting networks. Both approaches produced the same result: significant decreasing trends in tornado frequency across portions of Texas, Oklahoma, and northeastern Colorado. Significant increasing trends in portions of Mississippi, Alabama, Arkansas, Missouri, Illinois, Indiana, Tennessee, and Kentucky. The tornado corridor was moving east, not in a subtle, ambiguous, could-be noise way, in a statistically significant, confirmed by 2 independent methods way. Gensini was direct about what it meant. More folks are generally at risk because of that eastward shift, he told PBS NewsHour on the day the study published. The shift was dangerous, not just because more tornadoes were occurring in the east, but because of what the east is. Bigger territory, more people, different terrain, different housing, and Gensini had continued watching the trend in the years since. By 2025, he was telling the OU Daily, it's still more prevalent in the southeast, and we're seeing more evidence of that each year. This wasn't the first time researchers had noticed that the Deep South had a severe tornado problem. The term Dixie Alley had been coined in 1971 by Alan Pearson, who was then the director of the National Severe Storms Forecast Center, the predecessor institution to today's Storm Prediction Center. Pearson recognized that the region stretching from eastern Texas and Arkansas across Louisiana, Mississippi, Tennessee, Alabama, Georgia, and into the Carolinas had its own distinct tornado climatology, separate from, and in some ways more dangerous than the classic Great Plains pattern. The term sat somewhat dormant in popular awareness for decades, invoked by regional meteorologists who knew the Deep South's tornado statistics and frustrated by the national media's persistent focus on Oklahoma and Kansas. What the Gensini-Brooks study did was provide the quantitative confirmation that Dixie Alley wasn't just a permanent feature of the American severe weather landscape, it was a growing one. The NOAA probability maps tell the same story in visual form. From 1955 to 2024, the historical likelihood of a tornado touching down in any given year across southern Illinois, western Kentucky, and western Tennessee ranged from 60 to 70%. Meaningful, but not exceptional. Roughly consistent with the outer margins of traditional tornado alley. But when you narrow the window to the most recent 3 decades, 1994 to 2024, the same region shows a 90 to 100% annual tornado likelihood, every single year, in places like Paducah, Kentucky, in places like Cape Girardeau, Missouri, in places that the maps still shade as moderate risk at best. And here's the number that stops the investigation cold for a moment. Even by the older metric of raw tornado frequency, the 4 deadliest states for tornadoes in the United States are not Oklahoma, Kansas, Texas, or Nebraska. According to NOAA data, the 4 deadliest states are Alabama, Missouri, Tennessee, and Arkansas. Not deadliest in the sense of most tornadoes. Deadliest in the sense of most deaths. The storms in those states kill more people, per storm, than the storms in the states the country treats as the heart of tornado country. That gap between where the public thinks the danger is and where the danger actually lands is what this investigation is about. Stephen Strader has a title at Villanova University that is worth sitting with for a moment, Associate Professor of Geography and the Environment. He describes his focus as disaster geography, the study of how natural hazards interact with the human landscape, how the same storm produces a different outcome depending on who is in its path, what they're living in, and how much warning they can actually use. In 2024, Strader published a study in NPJ Natural Hazards alongside Victor Gensini and Walker Ashley, also of Northern Illinois University. The study examined 40 years of data on 2 variables simultaneously: how tornado risk had changed geographically from 1980 to the present, and how societal exposure, the number and type of homes and people in the path of that risk, had changed over the same period. The finding is the most alarming statistic in this investigation. The combination of increasing tornado risk in the Mid-South and increasing vulnerable population in that same region had produced, since 1980, a 3-fold increase in Mid-South housing exposure to tornado impact potential. Not 50%, not double, 3 times. And even in the Southern Plains, where the Gensini-Brooks research showed tornado risk had actually decreased, the growth in population and development in that region meant that a more than 50% increase in mean annual tornado housing impact potential had occurred anyway. You can have fewer tornadoes and still have more disaster potential if enough people build enough homes in the remaining path. To understand why the Mid-South number is so staggering, you have to understand manufactured housing, not as an abstraction, but as a statistical reality. Manufactured homes, what most people call mobile homes, represent approximately 6% of the total housing stock in the United States. 6%, a small minority of American homes. Yet, from 1985 to 2017, according to research by Strader and Ashley, published in the journal Weather, Climate, and Society, manufactured homes accounted for 54% of all housing-related tornado deaths. More than half, from 6% of the housing stock. The National Weather Service is unambiguous about the math. When you are in a manufactured home during a tornado, you are 15 to 20 times more likely to be killed than when you are in a permanent structure. The reason is structural, and it is specific. The primary cause of fatality in manufactured homes during tornadoes is anchor failure. When the anchor system fails, when the straps and tie downs connecting the home to its foundation give way, the entire structure becomes airborne. It doesn't matter how well the walls were built. It doesn't matter if the windows are reinforced. When a manufactured home leaves the ground, the physics are unforgiving. Federal regulations require that manufactured homes be anchored. The Manufactured Housing Association of Oklahoma visited NOAA's National Severe Storms Laboratory in 1994 and lobbied the National Weather Service to remove language about mobile home danger from tornado warnings, arguing that improved construction and tie-down regulations had made the warnings unnecessarily alarming. Harold Brooks of NOAA examined the fatality data at the time. The fatality rate in manufactured homes had not improved. On March 3, 2019, an EF4 tornado with winds of 170 miles per hour struck Lee County, Alabama. 23 people died. Auburn University engineer David Ruesch led the subsequent damage analysis. His finding: 19 of the 23 deaths occurred in manufactured homes. In every one of those 19 homes, the anchor system was absent or insufficient. That was not a failure of storm intensity. The storm was violent, but EF4 tornadoes are survivable in properly constructed permanent structures with adequate shelter. It was a failure of the housing stock, a failure that was known, documented, and had not been fixed. The Southeast has the highest concentration of manufactured homes in the United States. The region where tornado risk is measurably increasing is also the region with the most homes that offer 15 to 20 times greater likelihood of death when a tornado arrives. That is the threefold trap: storms moving east, more people in their path, and the homes those people are living in are the most dangerous place to be when the storm arrives. In the 1880s, a geologist and explorer named John Wesley Powell, best known for leading the first documented expedition through the Grand Canyon, made an observation about the American landscape that would prove remarkably durable. Standing at the 100th meridian west, roughly the eastern edge of the Dakota Badlands and the western edge of settled agricultural country, Powell noted a sharp transition. West of that line, sparse vegetation, dryland farming, empty country. East of it, corn, rain, density. He proposed that the 100th meridian marked a fundamental divide in the continent's climate, and that any agricultural policy that failed to account for it would eventually fail. Powell was right, and in 2018, a team of researchers at Columbia University led by Richard Seeger confirmed it with modern atmospheric data, publishing their findings in the journal Earth Interactions. What they found was not only that Powell's boundary was a real, sharp, physical climate divide, confirmed by drought patterns, precipitation records, soil moisture measurements, and satellite vegetation data, but that it was moving. The boundary between the wetter eastern United States and the drier western United States has shifted approximately 140 miles eastward since the late 1800s. What was once the 100th meridian is now closer to the 98th. The desert southwest is expanding. The aridity that once stopped at the Oklahoma-Kansas borderlands is creeping into territory that was once reliably moist. This is not a distant abstraction. Ernest Agee, professor emeritus of atmospheric science at Purdue University, has written in The Conversation that this boundary, what meteorologists call the dry line, can be a boundary for convection, the rising of warm air and sinking of colder air that can fuel storms. The dry line is not just a farming boundary, it is a storm initiation boundary. It is one of the primary mechanisms by which the atmospheric ingredients for tornado formation converge: warm, moist, Gulf air on one side, dry, cooler air on the other. Where they meet, convection ignites. And as the dry line moves east, the ignition zone moves with it. Harold Brooks of NOAA's National Severe Storms Laboratory has stated that climate simulations strongly suggest the 100th meridian should move east as the planet continues to warm, driven by the expansion of the dry southwest United States under current warming trajectories. Victor Gensini told CBS News directly, "It's not a big jump to say that climate change is causing the shift east. The hypothesis and computer simulations support what we are observing and what we expect in the future. There is appropriate scientific caution here, and this investigation will honor it. Gensini has been consistent in saying that he cannot confirm climate change as the definitive cause, that what he can say is that the shift looks exactly like what climate models predict, and that the evidence accumulates each year. Harold Brooks has noted that the dry line hasn't moved far enough on its own to fully explain the observed change in tornado climatology, that other mechanisms are likely involved. The science is honest about its uncertainty, but the trend is not uncertain. The dry line has moved, the tornado corridor is following. And the destination of that movement is a region of dense population, heavy forest, manufactured housing, and a warning infrastructure built for a different geography entirely. The 2025 tornado season added another data point. Illinois confirmed 146 tornadoes for the full year, the second highest total in the nation, behind only Texas. Illinois, not Oklahoma, not Kansas, Illinois. The line has moved. The question is what lies on the other side of it, and whether the people living there understand what that means. Picture the tornado you know, the one from every documentary, every news package, every stock footage library. A dark funnel, cleanly defined against a green-gray sky, hanging below a rotating wall cloud, visible from 3, 4, sometimes 5 miles away across flat Kansas pasture. Storm chasers positioning their vehicles, calculating the intercept angle. Minutes of visual warning. A thing you can see. Now set that image aside, because it has almost nothing to do with what happens when a significant tornado forms in the Deep South. The dominant storm type in Dixie Alley is what meteorologists call a high precipitation supercell. Unlike the classic plain supercell, which forms in relatively dry air and presents the tornado like a centerpiece hung below the storm's visible structure. The high precipitation supercell is saturated with moisture, drawn relentlessly northward from the Gulf of Mexico. The storm wraps itself in rain, heavy, torrential, blinding rain. And the tornado, if one forms inside that rain, not outside it, not visible below a photogenic wall cloud, inside a wall of water that is indistinguishable to the naked eye from the rain surrounding it. Brian Konecki, a meteorologist with the National Weather Service office in Jackson, Mississippi, captured this reality precisely. Down here in the southeast, we've got a lot more trees, so it makes them harder to see. He was talking about the terrain compound, the rolling hills, the dense forest cover, the ridge lines that block sight lines in every direction. But both factors matter. You cannot see the tornado because the storm has wrapped it in rain. And even if the rain parted for a moment, you cannot see it because the terrain and forest have eliminated the horizon. Victor Gensini, in an interview with CNN, was equally direct. Unlike the plains, where a tornado can be seen coming from miles away, the South has more rugged terrain and more trees, making it more difficult to spot a tornado. The practical consequence is not abstract. During the March 2025 outbreak, a tornado emergency was issued for Lindsay, Arkansas, the highest urgency warning category in the NWS system, reserved for situations involving a confirmed, violent, or catastrophic tornado. The tornado emergency for Lindsay was credited by local emergency managers with preventing additional casualties. The reason it was issued wasn't because the tornado was visible. It was because Doppler radar indicated a significant circulation moving directly toward a populated area, and residents were warned to take shelter immediately, even though no one could see the tornado coming. It was, in the language of the NWS, completely rain-wrapped. Now add darkness. The instability that drives supercell thunderstorm development on the Great Plains is primarily daytime-driven. Afternoon heating of the surface destabilizes the atmosphere. Thunderstorms fire in the late afternoon and early evening, and the outbreak largely winds down after sunset as surface heating diminishes. The Southeast operates on different physics. The Gulf of Mexico is warm. It is warm year-round, and its warmth maintains the supply of low-level moisture that sustains atmospheric instability long after the sun goes down. Deep overnight instability, the persistence of the storm-generating engine into the pre-dawn hours, is a structural feature of the Deep South severe weather environment, not an anomaly. The result? Dixie Alley tornadoes are significantly more likely than plains tornadoes to occur at night. Tennessee leads the nation by a considerable margin. Over 73% of Tennessee's tornado deaths occur at night. Arkansas, Mississippi, and Alabama all have majority nighttime tornado death rates, greater than 50% for each state. Consider what that means in practice. A 13-minute average tornado warning lead time, the national figure cited by NOAA as the current operational standard, is meaningful if you are awake, aware, within reach of a phone or radio, and in a structure where shelter is possible. At 2 in the morning, in a rain event loud enough to mask the sound of approaching winds, in a manufactured home where no interior room provides meaningful structural protection, that 13 minutes compresses to something far less useful. And if you don't wake up to the wireless emergency alert on your phone, if you sleep through it, if the phone is on silent, if you never got one because your cell carrier's coverage in your rural county has gaps, the 13 minutes becomes 0. Greg Carbon, the warning coordination meteorologist at the Storm Prediction Center, described the Dixie Alley seasonal pattern to Live Science this way. There they have a threat that kind of continues. No defined peak, no off-season of relative safety. The instability that produces tornadoes in the Deep South doesn't concentrate neatly into a 6-week window the way the Plains pattern does. It can arrive in January. It arrived in January 2025. A squall line on January 5th produced EF2 tornadoes in Louisiana, Mississippi, and Alabama. It arrived again in November. And December, the windows of seasonal complacency that families in other regions can reasonably rely on do not exist in Dixie Alley. Invisible, arriving in darkness, present in seasons that carry no warning in the public mind. And the storm is heading for a structure that the data says is 15 to 20 times more likely to kill its occupants than the house across the street. Let's go through the numbers slowly, because they deserve that. From 1985 to 2017, 32 years of confirmed post-event death records, 2,248 people were killed by tornadoes in the United States while inside structures. Of those, 1,603 deaths, 54%, occurred in manufactured homes. Manufactured homes that represent 6% of the total housing stock. The ratio is not a rounding error. It is not a data artifact from a particularly bad year. Stephen Strader of Villanova University and Walker Ashley of Northern Illinois University, who conducted this analysis in the journal Weather, Climate, and Society, were careful to note that if the catastrophic 2011 season were excluded from the calculation, the year that produced the April 27th super outbreak with its rash of violent tornadoes striking permanent neighborhoods, the manufactured home percentage would be even higher. An EF1 tornado produces winds between 86 and 110 miles per hour. That is the lowest category of significant tornado, the threshold below which a tornado is classified as weak, and above which it is considered capable of structural damage. An EF1 tornado will largely pass through a well-built permanent home, removing some shingles, breaking windows, perhaps damaging the roof. The walls stand, the occupants survive. The same EF1 tornado striking a manufactured home can completely destroy it, not damage it. Destroy it. The National Weather Service is explicit about this, and the reason is anchoring, or the failure of it. A manufactured home that is properly anchored to a concrete foundation with straps securing the frame at calculated intervals has meaningfully improved survival odds, even in stronger tornado conditions. The structure may be catastrophically damaged, but the anchor system prevents the home from becoming a projectile. It stays on the ground, and staying on the ground is the difference between damaged walls and an airborne structure that comes apart in 300 milliseconds. In 2019, David Ruesch, an engineer at Auburn University, led the damage survey team for the March 3rd AF4 tornado that struck Beauregard and Smith Station in Lee County, Alabama. His team examined every fatality location. 19 of the 23 deaths occurred in manufactured homes. In every single one of those 19 homes, the anchor system was absent, or the anchors present were insufficient for the wind loads they were theoretically designed to survive. Not some of them, everyone. Federal regulations require manufactured homes to be anchored. The HUD code governing manufactured housing construction and installation has required anchor systems since the 1970s, but federal installation standards are enforced at the state level, and enforcement is chronically inconsistent. In many rural counties across the Deep South, the installation inspection that is supposed to verify anchor system compliance simply does not occur. The home is installed. The inspector is either not dispatched or lacks the resources for adequate follow-up. The family moves in. The anchor system may or may not be adequate. Harold Brooks of NOAA examined this problem from the data side after the 1994 lobbying effort by the manufactured housing industry. The argument from the industry was straightforward. Improved construction methods and updated federal standards had made manufactured homes significantly safer than older data suggested. Brooks reviewed the actual fatality numbers. The percentage of tornado deaths occurring in manufactured homes had not decreased. The improvements in construction, whatever their real-world merit, had not been reflected in the death statistics. The geography of manufactured housing density in the United States is not random. It concentrates in rural areas, in the South, and in lower-income communities. The states with the highest manufactured housing percentages include Mississippi, South Carolina, Louisiana, Alabama, and West Virginia. These are not states on the periphery of the emerging tornado corridor. They are states at its center. Over 79% of at-home tornado deaths in weaker tornadoes, storms with winds below 135 miles per hour, occurred in manufactured housing, not in the violent ground-scouring EF5s that make national news. In the moderate, relatively common events that an EF2 or EF3 classification produces in the Deep South on an average severe weather day. The Southeast also does not have basements. This matters more than it might seem. The geology of much of the region, clay-heavy soils, high water tables, terrain that floods readily, makes below-grade construction either structurally difficult or financially prohibitive. In Kansas or Nebraska, a family in a permanent home with a basement hears a tornado warning at 2 a.m. and goes downstairs. In rural Tennessee, the same family in the same situation goes to an interior bathroom, a bathroom that offers psychological comfort but almost no structural protection if the roof fails. And in a manufactured home, the question of which interior room to shelter in is nearly moot. When the anchor system fails, the interior rooms travel with the structure. The housing problem wasn't hidden. It was documented in 1994, 22, 2019, and 2024. The data kept arriving, and the fix kept not happening, and the storms kept going east. And this is where the story takes a turn that most people haven't heard about. May 16th, 2025. The Storm Prediction Center issues a public severe weather outlook for the central and eastern United States. The language is specific: widespread damaging winds, some hurricane force, several tornadoes, a few intense, widespread large hail, some baseball size. This is not routine language. This is the SPC telling emergency management professionals and the public that a major severe weather event is incoming. By the afternoon of May 16th, the SPC issues a tornado watch for eastern Kentucky. By evening, a powerful storm system has already carved a path across eastern Missouri, dropping damaging tornadoes. At 11:08 p.m., the National Weather Service issues an upgrade, a life-threatening situation designation, added to active tornado warnings for the region. Not a standard tornado warning. The elevated tier reserved for events producing or expected to produce significant damage and casualties. The tornadoes arrive in the pre-dawn hours of May 17th. In Pulaski and Laurel counties in eastern Kentucky, Somerset, London, an EF4 tornado with winds estimated at 165 miles per hour strikes residential areas. 19 people are killed. In Selmer, Tennessee, a separate EF3 tornado with winds of 160 miles per hour tears through McNairy County, killing 5 people and leaving a damaged footprint of 108 structures, including 32 that are completely destroyed. Many of those structures are manufactured homes pulled from their concrete slabs by winds that the anchor systems were not adequate to resist. McNairy County had been struck by a different tornado less than 2 years earlier, killing 9. the same county, twice in 24 months. The National Weather Service issued the warnings. The lead times were maintained. Residents received alerts on their phones. The system, by the technical definition of its mission, worked. 27 people died across Kentucky, Missouri, and Virginia over the course of that weekend. Now here is what was happening inside the warning system while the storms were building. The National Weather Service office in Jackson, Kentucky, the office with primary responsibility for issuing tornado warnings for the counties most severely struck, was one of at least 4 NWS offices across the country that had lost its permanent overnight forecaster. Tom Fahey, the legislative director for the NWS Employees Organization, the union that represents National Weather Service meteorologists, confirmed this to the New York Times and to multiple other news organizations. The staffing reduction was a consequence of cuts implemented as part of the Department of Government Efficiency Initiative, DOGE, which in early 2025 had resulted in the dismissal of hundreds of NOAA employees, including NWS forecasters. NOAA acknowledged the situation to Newsweek directly. Several local NWS offices are temporarily operating below around-the-clock staffing. NWS is mitigating impacts by temporarily reassigning meteorologists and directing nearby offices to provide additional support. Temporarily reassigning other offices, on May 16th, the Jackson office recognized the severity of what was developing. The staff called everyone in, voluntary surge staffing, drawing on their own off-clock time and coordinating with neighboring forecast offices. They maintained coverage. The warnings were issued with appropriate lead times. Tom Fahey from the union was clear. The staffing shortage did not affect warning accuracy or timeliness on that specific night. But an anonymous NOAA employee, speaking to CNN, described the broader structural problem with a precision that is worth quoting carefully. With so many NWS offices short-staffed across the country, it becomes increasingly difficult to shuffle staff for severe weather, flooding, fires, and the upcoming hurricane season. Despite heroic efforts, like in Jackson, you eventually just run out of people, until hiring can begin again. Heroic efforts. Eventually, run out of people. And there was a second, quieter failure that received less attention than the staffing story. A separate atmospheric data gap revealed during an Easter weekend severe weather event in April of 2025. The NWS, as part of standard operational procedure, launches weather balloons twice daily, at specific times corresponding to global atmospheric observation windows. These radiosondes ascend through the atmosphere, measuring temperature, humidity, wind speed, and wind direction at every level from the surface to the stratosphere. That data feeds into the numerical weather prediction models that forecasters use to assess storm potential hours and days in advance. During the April severe weather event, the 7 p.m. weather balloon launch from the Omaha Area Forecast Office, scheduled for a time when thunderstorms were already developing in eastern Nebraska, did not occur. Budget reductions and staffing cuts had led to a reduction in balloon launch frequency at multiple sites. Chris Vagaski, a research program manager for Wisconsin at the University of Wisconsin, told NBC News exactly what that meant in practice. At 3 p.m. that afternoon, a balloon had been launched. Its data showed the atmosphere was a hail threat, not a tornado threat. Atmospheric instability present, but wind shear not configured for significant tornado development. Before the staffing cuts, the Weather Service would have released another regularly scheduled weather balloon at 7 p.m., just as tornadoes started to pop up in Nebraska. On Thursday, it didn't. We didn't get to see how the atmosphere had evolved between 3 p.m. and 7 p.m. to understand how did the atmosphere evolve, so that now we're getting tornadoes instead of hail. The warnings were ultimately issued at the right time. Radar confirmed the rotation once the storms developed. But the data that might have allowed earlier confidence, earlier preparation, earlier warning wasn't there. Because the balloon didn't fly, the National Warning System for tornadoes has been improving for decades. Lead times have climbed from near zero in the 1970s to an average of 13 minutes nationally today. That improvement has saved lives. The question this investigation raises isn't whether the system works. It is whether a system under staffing stress, serving a storm corridor it was not originally designed for, with data collection infrastructure that has been trimmed, can maintain that performance as the storms concentrate in new geography. Let's step back from the individual threads, the atmospheric shift, the manufactured housing mortality data, the visibility problem, the warning infrastructure strain, and look at them as a single system, because that is what they are. Walker Ashley of Northern Illinois University, a researcher who has spent his career studying the intersection of severe weather and human geography, has described what he calls the bullseye effect. As suburban and exurban development expands outward from cities, as housing spreads into areas that were previously farmland or forest, the probability that any given tornado will strike a populated area increases. The tornado doesn't have to be stronger. It doesn't have to be more frequent. It just has to travel through territory that now has people in it where it previously did not. Victor Gensini, speaking to CNN in March 2019 after an Alabama outbreak, stated the implication directly. Even with fewer tornadoes in the future, or the same number, we're going to have more of these tornado disasters, like we saw yesterday, because our exposure is continuing to grow. Think about what the compound system looks like in practice. Imagine two EF2 tornadoes, same wind speed, same path length, same time of year, same warning lead time of 13 minutes. Tornado 1 forms in rural central Kansas at 4 p.m. on a May afternoon. The sky is clear enough that spotters confirm the funnel from 3 miles away before it touches down. Radar operators have been tracking the supercell for 40 minutes. The tornado moves northeast across wheat fields. It strikes a farmstead, a well-built permanent structure, no basement, but a reinforced interior hallway. The family shelters, the roof is damaged and several outbuildings are destroyed. No casualties. Tornado 2 forms in rural western Tennessee at 1:45 a.m. on a March morning inside a high precipitation supercell. The storm has been producing heavy rain for 2 hours. The tornado is completely rain-wrapped, no visual confirmation possible from the ground. The Doppler radar at the nearest WSR-88D facility picks up the rotation couplet, and the warning is issued 12 minutes before the tornado reaches the first structure. The tornado strikes a manufactured home community. The residents have received a wireless emergency alert on their phones. But 3 of the 7 homes in the community are occupied by elderly residents who don't wake to phone alerts. And the community has no storm siren because it falls in a coverage gap between 2 county emergency management zones. The anchor systems on 2 of the homes are inadequate. Those homes become airborne. Same wind speed, same path length, same 13-minute warning. Radically different outcomes. The compound system produces a fatality multiplier that no single variable accounts for. And in 2025, all 6 variables were simultaneously present across an entire season. The 2011 super outbreak serves as the historical reference point for what the Deep South can produce when these variables align at maximum intensity. April 27, 2011, the largest tornado outbreak ever recorded at the time. Over 300 people killed. 236 of those deaths in Alabama alone, in a single day. The outbreak remains the deadliest U.S. tornado event since 1925. It was not a Great Plains event. It was a Deep South event. It was an Alabama, Mississippi, Tennessee event. And every researcher who studies tornado climatology will tell you that the atmospheric conditions producing the April 27, 2011 outbreak are not becoming rarer. They are becoming more common. EF4 and EF5 tornadoes, the violent events that account for the catastrophic casualties, represent less than 2.5% of all tornado reports nationally. Yet, according to analysis of the National Centers for Environmental Information, Storm Events Database, they account for 76.5% of all tornado fatalities. That is the distribution, a tiny fraction of events, the overwhelming majority of deaths. And those events are disproportionately concentrated in the Deep South corridor. In 2025, the United States recorded 1,544 preliminary tornado reports, the 4th most active year since 2010. The states leading that count, Texas with 162, Illinois with 146, Missouri with 120, Mississippi with 111. Texas has always been at the top of that list. Illinois, Missouri, Mississippi, those are the states at the eastern margin of a corridor that is still moving. Tornadoes in Dixie Alley move faster than their plains counterparts. The jet stream is stronger, and storm motion frequently exceeds 50 miles per hour across the ground. That speed compresses response time even further. The warning is issued. The storm is already moving at highway speeds. The 13 minutes is real, but it is 13 minutes against a storm that is covering more than a mile a minute. This is the compound event, not any one catastrophic variable. 6 moderate ones, operating simultaneously, overwhelming systems built to handle them in isolation. Stephen Strader's 2024 study in NPJ Natural Hazards made a finding that deserves to be stated plainly without softening. Escalating vulnerability and exposure have outweighed the effects of spatially changing risk. Read that carefully. Even in a scenario where tornado frequency held perfectly constant, no shift, no increase, no change in the atmospheric pattern whatsoever, disaster potential in the Mid-South would still be increasing, because the people moving into the region and the housing they are moving into are creating a growing target. The exposure is expanding faster than any other variable in the equation, but tornado frequency in the Mid-South is not holding constant. It is increasing. The 2025 data shows this with uncomfortable clarity. 300 confirmed tornadoes in March, the month that produced the historic outbreak. 352 in April. 332 in May. 24 killer tornadoes across the full year, with March producing 11 of them in a single month, a concentration not seen in the modern record. And the season isn't staying within its historical calendar window. The January 5th, 2025 squall line produced EF2 damage in Louisiana, Mississippi, and Alabama, completely destroying a mobile home and a shop building in Marion, Louisiana, and tearing through multiple communities in the Deep South. January, the month that has historically been the quietest on the severe weather calendar for most of the country. The mechanism sustaining this pattern is documented. The Gulf of Mexico is warming. Warmer sea surface temperatures maintain deeper, low-level moisture through seasons and hours that the plains tornado engine does not reach. The overnight instability that produces Dixie Alley's nocturnal tornado signature is fed by that moisture continuously. As the Gulf warms, the moisture supply is sustained later into autumn and begins earlier in spring. The shoulders of the traditional tornado season expand. Victor Gensini has framed the seasonal disruption this way. The lack of a well-defined tornado season in Dixie Alley can lead to complacency among residents of the region, not because the residents are careless, because the human mind calibrates threat based on pattern. If tornado season has always meant April through June, a February warning produces a different psychological response than a May warning. The attention is lower, the shelter preparation is lower, the speed of response may be lower. The Vortex SE research program, Verification of the Origins of Rotation, in Tornadoes Experiment Southeast, was launched in 2016 specifically to study why the Southeast tornado environment is structurally different from the plains. The program has been running field campaigns, deploying mobile radar units and instrumented weather stations, and accumulating the kind of high-resolution data that operational NWS Doppler radar cannot provide for rain-wrapped, fast-moving Deep South supercells. The findings, when fully published, will be important, but the program has been running for nearly a decade now, and the policy changes, building code reforms, and public education updates that the science would seem to call for have not materialized at the scale the data warrants. By April 2026, as this investigation is being assembled, the 2026 tornado season is already confirming the continuation of the trend. 297 tornadoes have been confirmed through late April, with Illinois, Indiana, Michigan, and Arkansas among the leading states for activity. The trajectory isn't bending. And here's what that means concretely. The communities that were in the path in March 2025, that were in the path in May 2025, that were in the path in April 2026, many of them are still in the path. The same manufactured home parks, the same counties without community storm shelters, the same NWS offices managing their coverage areas with depleted staffing. The trend lines don't bend on their own. Something has to change them. There is a gap in this story that hasn't been named yet, and it is worth naming precisely. The peer-reviewed research on the eastward shift of tornado climatology is not new. Victor Gensini and Harold Brooks published their landmark study in 2018. The Columbia University Dryline research was published the same year. Stephen Strader's work on manufactured housing vulnerability has been accumulating since at least 2016. The Vortex SE field campaign has been running since 2016. The NOAA probability maps showing 90 to 100% annual tornado likelihood in southern Illinois and western Kentucky and western Tennessee have been generated from data going back to 1994. The science is not secret. It has been published in peer-reviewed journals, covered by outlets including The Washington Post, Scientific American, CBS News, PBS NewsHour, and National Geographic. It has been discussed at American Meteorological Society conferences. It has been cited in federal reports. The researchers involved have been doing interviews for years, and yet the public mental map of tornado risk in the United States has not updated. The term Tornado Alley still calls up an image of Oklahoma wheat fields and Kansas plains. School curricula in Mississippi and Tennessee and Kentucky still teach tornado safety in the context of a phenomenon that, statistically, is becoming more relevant to their students every year. But those curricula haven't been redesigned around the current data. FEMA risk maps and community preparedness messaging still lag the research by at least a decade. The real estate market in the emerging tornado corridor does not price tornado risk the way the real estate market in Moore, Oklahoma prices it, even as the data shows the tornado environments are converging. Anton Simon, a storm chaser and National Geographic explorer who has studied tornado climatology for decades, offers an important methodological caveat worth acknowledging. Some of what appears on the NOAA probability maps, the increased tornado likelihood in the southeast, reflects improved detection. More tornadoes are spotted and reported in populated areas than in sparsely populated ones, and the population of the Deep South has grown. This is a real confound that careful researchers account for. The Gensini-Brooks study accounted for it directly, using the Significant Tornado Parameter Index to track atmospheric conditions rather than reported tornado counts. The STP analysis showed the same eastward trend as the tornado report analysis. Better detection explains some of the apparent increase. It does not explain all of it. Harold Brooks, whose caution is characteristic, he is one of the more careful voices in the field, has nonetheless been explicit. Climate simulations strongly suggest the 100th meridian will continue moving east as the planet warms. The mechanism is not in dispute. The magnitude and pace of the shift are the subject of ongoing research. What the warning system is working to address is the detection problem specific to the Deep South environment. NOAA's Warn on Forecast project, a research initiative at the National Severe Storms Laboratory, is designed to shift tornado warnings from the current Warn on Detection approach to a Warn on Forecast approach. The distinction matters enormously. Under the current system, a tornado warning is issued when Doppler radar detects rotation in a thunderstorm, a system that produces, on average, 13 minutes of lead time and a false alarm rate of approximately 75%. Under Warn on Forecast, high-resolution numerical weather prediction models running continuously through a storm's life cycle would identify tornado potential before radar confirms rotation, potentially increasing lead times to 20, 30, or more minutes. The program has demonstrated real capability. In 2019, a team led by Gensini, using extended-range forecasting techniques related to the Madden-Julian Oscillation, a major eastward-moving atmospheric disturbance, accurately predicted the May 2019 tornado outbreak nearly 4 weeks before it occurred. During that 13-day stretch in May, 374 tornadoes touched down, more than triple the average. The 4-week prediction was published, and it was correct. The path from research capability to operational deployment in every at-risk NWS forecast office is not short. It requires funding, hardware, training, and staffing. 3 of which are currently constrained across the agency. Troy Kimmel, an independent incident response meteorologist and former professor at the University of Texas at Austin, told The Hill that the push toward automated forecast products for extended time horizons concerned him specifically because of the Deep South environment. These are all a matter of atmospheric changes that are taking place, and the Weather Service has to be able to respond to them, he said. The Southeast's rapid evolving storm environments, its unusual terrain interactions, its rain-wrapped supercells. These are exactly the situations where locally based, experienced forecaster judgment adds value that no automated model currently replicates. The gap between what the science says and what the public knows. The gap between what Warn on Forecast can do in research mode and what it can do as a deployed operational system. The gap between the building codes that exist and the enforcement mechanisms that don't. These are not gaps born of ignorance. They are gaps born of the pace at which institutions change relative to the pace at which the atmosphere is changing. Stephen Strader, in describing the practical reality of tornado warning response for a family in a manufactured home in the Deep South, offered an image that deserves to be held in full. Not summarized, rendered completely. If the warning is 13 minutes away and you're 20 minutes away from your shelter, it's the middle of the night. You have 2 kids, you have to get them out of bed. Your car is outside, it's raining, it's lightning. What do you do? What do you do? The question is not rhetorical. It is the operational reality for millions of families in the emerging tornado corridor on any night with a particularly dangerous situation tornado watch in effect. And it is a question the current warning and shelter infrastructure does not have a good answer to. 13 minutes is the national average tornado warning lead time, a number that represents a genuine triumph of atmospheric science and investment in Doppler radar technology. In the 1970s, before the modernization of the National Weather Service radar network, the average lead time for a tornado warning was close to 0. The storm had already touched down before the warning was issued. The improvement to 13 minutes has saved lives that cannot be counted because the counterfactual is invisible. We know what the statistics look like now. We can only infer what they would have looked like without the warnings. But 13 minutes assumes a family that is awake, alert, in reception of the warning, and within 13 minutes of adequate shelter. In the Deep South, at 2 in the morning, in a manufactured home in a rural county where the nearest community storm shelter is a 20-minute drive away, on a road that is now flooded by the same storm system producing the tornado, none of those assumptions hold. The shelter gap in the southeast is not a new discovery. The geology of the region makes below-grade construction either technically difficult or financially prohibitive for many homeowners and manufactured home park operators. Clay-heavy soils expand and contract with moisture. High water tables in low-lying areas, exactly the terrain where manufactured home communities often develop, where land is cheap, make basement excavation costly and flood-prone. Winters in the Deep South have historically been mild enough that below-grade construction was never integrated into the regional building tradition. NOAA and FEMA are explicit. They recommend that residents of manufactured homes leave for sturdier shelter before storms with tornado potential arrive. The recommendation is sound. It assumes the family has somewhere to go that is accessible, that they know where it is, and that they have the time and transportation and awareness to get there before the storm does. For many rural manufactured home communities in western Tennessee, northern Mississippi, and the Arkansas Ozarks, none of those assumptions are consistently true. FEMA community safe rooms do exist in parts of the Deep South. These are FEMA-rated shelters engineered to withstand EF5 winds, the most violent tornado category. They represent a genuine tool, but they were not built at the scale or density that the current tornado risk in the region would justify. And even where they exist, a safe room that is accessible during business hours, or that requires driving to reach on a dark, wet highway at 1 a.m. while a tornado is already on the ground, does not function as a life safety resource in the scenarios where it is most needed. The warning chain is complete and functioning. The SPC issues the watch. The local NWS office issues the warning. The emergency alert system interrupts broadcast radio and television, and wireless emergency alerts push to every cell phone in the warned polygon. The technology works. The 13 minutes ticks off, and then the system reaches the end of what it can do. What happens in those 13 minutes in a specific home in a specific county depends entirely on variables the warning system does not control: the structural integrity of the shelter, the distance to the nearest safe location, the awareness of the resident about what take shelter immediately means when you don't have a basement, and whether the road between you and safety is navigable in a severe thunderstorm. The 75% false alarm rate creates an additional layer of complexity. When 3 out of 4 tornado warnings do not produce a tornado at a specific location, the behavioral response to warnings erodes over time. This is documented. Warning fatigue is a real phenomenon in communities that receive frequent tornado watches and warnings. A family that has heard 7 warnings in the past 3 years and has never seen a tornado tends to take the 8th warning less seriously than a family receiving their first. In the Deep South, where the emerging tornado corridor is producing warnings at higher frequency across communities that historically experience them rarely, the warning fatigue problem is specifically acute in exactly the communities that most need rapid, confident response. This is not a solvable problem through better radar. The radar is working. The warnings are being issued. The gap is structural, geographic, and social, and it is widening as the storms increasingly concentrate in the places least equipped to respond to them. Every thread of this investigation converges on a single weekend in May 2025, not because it was the worst tornado event in American history. It wasn't. Not because the warnings failed. They didn't. But because it demonstrated, with a precision that no model or projection could replicate, exactly what happens when every compound factor in this story operates simultaneously in the same geography. May 15, 2025. One day before the outbreak, the Storm Prediction Center has been tracking the developing system. The pattern is familiar by this point in the season: a powerful upper-level trough ejecting across the central United States, a low-pressure center deepening rapidly, Gulf moisture streaming northward into an already primed atmosphere. The SPC issues its outlook. The Mid-South and Ohio Valley face a significant severe weather threat. The watches begin to be posted for portions of the affected region. May 16th, the NWS office in Jackson, Kentucky recognizes what is coming. The office's meteorologists review the staffing situation. The Jackson office, as has been documented by multiple news organizations, including the New York Times, is one of at least 4 NWS forecast offices nationwide that had lost its permanent overnight forecaster as a result of DOGE-related staffing reductions earlier in 2025. On a routine, non-threatening overnight, this means the office operates with reduced staff, acceptable risk management during quiet weather. On the night of May 16th, it is not quiet weather. The Jackson staff calls everyone in. The office reaches out to neighboring forecast offices, Paducah, Louisville, for surge staffing coordination. By the time the storm system is producing confirmed tornadoes in Missouri, Jackson is fully staffed. The warnings are ready. At 11:08 p.m., the Jackson office upgrades active tornado warnings to include the life-threatening situation designation, the highest urgency language in the NWS warning vocabulary, not a standard tornado warning. The rare escalation that says, "This is particularly dangerous, take shelter immediately." In Somerset and London, Kentucky, Pulaski and Laurel counties, an EF4 tornado with winds estimated at 165 miles per hour strikes in the pre-dawn hours of May 17th. 19 people die. The warnings were issued. Residents received wireless emergency alerts. Some got to safety. 19 did not. In Selmer, Tennessee, McNairy County, an EF3 tornado with winds of 160 miles per hour arrives around the same time. 5 people are killed. 14 are hospitalized. 108 structures are impacted. 32 destroyed. The Center for Disaster Philanthropy's documentation of the event is specific about the housing. Many of the impacted structures were mobile homes that were torn away from their concrete slabs. The anchor systems failed. McNairy County had already buried 9 people from a tornado less than 2 years earlier. The community was not unprepared in the sense of being unaware of tornado risk. It was unprepared in the sense that the structures people were living in could not survive a storm the atmosphere had decided to deliver. In Sladen, Mississippi, April 2nd of the same year, an EF3 tornado with winds of 150 miles per hour strikes during the earlier April outbreak, moving into Grand Junction, Tennessee. In Senatobia, Mississippi, another EF3 produces wind speeds of 160 to 165 miles per hour, the strongest recorded in the Mid-South during the recent outbreak sequence. At least 80 homes damaged in northern Mississippi, 6 people injured. The NWS Union's Tom Fahey was clear with the press. The staffing shortages did not affect the accuracy or timeliness of the tornado warnings for the May 16th event. The surge staffing worked. The warnings were right. The NOAA spokesperson confirmed the same to Newsweek. 27 people died across Kentucky, Missouri, and Virginia over that weekend. Now ask the question that this investigation was built to ask. What would the outcome have been if the storm system had been 30% stronger? If the EF4 in Pulaski County had been an EF5, if the storm's track had been 10 miles south, striking a more densely populated mobile home corridor, if the Jackson NWS office had not been able to assemble surge staffing because 4 other offices in the region were simultaneously drawing on the same pool of available meteorologists for their own ongoing events. These are not hypotheticals designed to alarm. They are the questions that atmospheric scientists, warning specialists, and disaster geographers are actively studying, because the compound system doesn't hold still. The trend lines that Cincini has been tracking since 2018, that Strader has been modeling since 2016, that the Vortex SE campaign has been measuring since the same year, those trend lines continue. The May 2025 event is a case study. It is also a preview. I want to address something directly, because it deserves an honest answer, grounded in physics rather than dismissal. After every major tornado outbreak in the Deep South, after the March 2025 outbreak, after the May 2025 Kentucky disaster, after the April 2025 system, a specific set of claims circulates with significant velocity on social media. That the storms were engineered, that HAARP, the High Frequency Active Auroral Research Program, was responsible, that government-directed atmospheric manipulation produced or steered the tornadoes, that chemtrails or directed energy weapons played a role. These claims are not correct, and I'm going to explain precisely why, not because the people asking these questions are foolish, but because the questions come from a rational place. When something catastrophic and seemingly disproportionate happens to a community, the mind reaches for an agent, someone who allowed this, someone who caused this. The impulse to find a human actor behind a devastating event is not paranoia. It is human. And the people circulating these claims after a tornado disaster in Kentucky or Mississippi are largely people in genuine grief looking for an explanation that feels adequate to the scale of what happened. HAARP is a real facility. It sits in Gacona, Alaska, and it is operated by the University of Alaska Fairbanks. It is a legitimate atmospheric research tool. The High Frequency Active Auroral Research Program uses radio frequency transmission to heat small patches of the ionosphere and study the results. It has been used for research on radio wave propagation, communications, and upper atmospheric physics. Since 2015, it has been a civilian research facility, transferred from the Air Force Research Laboratory to the university. Its peak transmission power is approximately 3.6 megawatts. A supercell thunderstorm, a single supercell, not an outbreak, releases energy on the order of 10 to the 17th joules over the course of its lifetime. That figure comes from standard atmospheric physics, not classified research. 10 to the 17th joules. HAARP's total power output, running continuously for an hour, is on the order of 13 billion joules. The energy difference between HAARP's operational capacity and the energy required to generate the convective processes associated with a tornado-producing supercell is not a gap that better technology could bridge. It is a gap of physical scale that makes the mechanism impossible by definition. There is also a geometry problem. HAARP heats the ionosphere, the outermost layer of Earth's atmosphere, at altitudes above approximately 50 miles. Tornadoes form in the troposphere, the lowest layer of the atmosphere, at altitudes typically below 10 miles. The physical pathways by which ionospheric heating could produce organized convective structures in the troposphere are not theoretical possibilities awaiting confirmation. They don't exist in the documented physics of the atmosphere. The desire for a controllable explanation is understandable, but the actual human fingerprints in this story are real, documented, and in some cases actionable. The policy decisions that left manufactured home anchor enforcement chronically underfunded. The federal budget choices that reduced NWS overnight staffing in the most vulnerable forecast regions, the building codes that never required storm shelters in the states with the highest tornado death rates, the decades of public education that pointed the country's severe weather attention toward Oklahoma and Kansas, while the data quietly showed the center of gravity shifting east, the development patterns that placed manufactured home communities in tornado-prone terrain without adequate community shelter infrastructure. Those are human decisions. They have human consequences. They are traceable, and they are worth the sustained attention this investigation is giving them. The real story doesn't need a conspiracy. The ordinary science of a shifting atmosphere, combined with the ordinary policy failures of an unprepared region, is alarming enough. More than alarming enough. This investigation has now assembled the evidence. What remains is the harder task, the one that separates rigorous investigation from advocacy. There are three credible interpretations of what the data shows. All three are grounded in the same peer-reviewed research. All three deserve to be presented fairly. And the honest answer is that the data available right now does not definitively confirm which of the three is correct. What would distinguish between them will become clearer over the next decade if the atmospheric and societal trend data continues to be collected and published, and if the institutions responsible for that collection remain adequately funded to do the work. The eastward shift in tornado climatology is real, statistically significant, and well documented, but it represents a gradual transition occurring over decades, not a sudden rupture that has already overwhelmed the warning and shelter infrastructure. The dry line is moving, but Harold Brooks himself has noted it hasn't moved far enough on its own to fully explain the observed tornado frequency changes, which means other mechanisms, potentially including natural decadal climate variability, are contributing to the pattern. Detection improvements, more spotters, more populated areas, more sophisticated public reporting account for some portion of the apparent increase in Deep South tornado reports. On this interpretation, the warning system is stressed but not broken. The NWS surge staffing on May 16th worked. The warnings were issued. Lead times were maintained. The Warn on Forecast project is advancing toward operational deployment, which will extend lead times further. FEMA community shelter programs are expanding in at-risk regions. Manufactured home construction standards have improved, even if enforcement is inconsistent. The 2025 tornado season, while extraordinary, the record March outbreak, the costly April system, the deadly May system occurred against the backdrop of a La Niña to El Niño transition year, which historically drives elevated severe weather activity in the Deep South corridor. That transition is not a permanent state. The prescription on this interpretation: continued investment in Warn on Forecast deployment, expanded community shelter programs in the Mid-South, improved manufactured home anchor inspection enforcement, and updated public education materials to reflect the current NOAA probability maps. Serious, sustained work, but work within the existing institutional framework. Interpretation: 2. A structural problem requiring structural response. The trend is real, significant, and driven by forces: the warming Gulf, the expanding dry Southwest, the shifting dry line, that are not natural variability. They are the measurable signature of ongoing atmospheric change. Victor Gensini has been consistent for 7 years. This is what you would expect in a climate change scenario. The Strader-Gensini-Ashley 2024 study found that exposure and vulnerability are already outweighing the effects of risk change, meaning the disaster potential in the Mid-South is growing faster than any warning technology improvement can compensate for, because the denominator of vulnerable people and homes is expanding faster than the numerator of protected people. The NWS staffing situation is not a temporary aberration. It is a structural fragility, the product of personnel cuts applied to an agency whose workload is increasing as the storm corridor expands. Surge staffing works when nearby offices have surplus capacity. The anonymous NOAA employee's warning to CNN was precise. You eventually just run out of people. The weather balloon reduction is not a minor adjustment. Upper air data is the backbone of numerical weather prediction. Fewer soundings mean less confidence in model initialization, which means slightly lower forecast accuracy at the margins. And, in severe weather forecasting, the margins are where the warnings live. On this interpretation, the 2025 season is not an extreme outlier. It is the leading edge of a new normal. What is required is not incremental investment, but a genuine structural response. Mandatory storm shelter requirements in manufactured home parks in the emerging tornado corridor. Aggressive enforcement of existing anchor system regulations with federal oversight. Significant NWS restaffing, not just to previous levels, but to the higher levels warranted by an expanded severe weather geography. Accelerated warn-on-forecast deployment prioritized for Deep South forecast offices. And a public education campaign that replaces the decades-old Tornado Alley mental model with the current scientific map. Interpretation. 3. The gap is already too wide. The compound system is operating beyond what incremental or even substantial institutional fixes can address in the time available. The dry line will continue east. The Gulf will continue warming. The manufactured housing stock in the most at-risk counties is growing, not shrinking. It is the most affordable housing option for rural and low-income families in a region where wages and land costs make permanent construction economically inaccessible. Building code reform in the Deep South faces political resistance that has not diminished despite decades of catastrophic tornado seasons. The NWS is losing institutional knowledge. The experienced meteorologists who understood the specific behavioral quirks of Deep South severe weather and who trained younger forecasters, faster than it can recruit and train replacements. And the most dangerous variable of all, on this interpretation, is the one that no technology addresses. The families living in manufactured home communities in western Tennessee and northern Mississippi and the Arkansas Ozarks still largely understand themselves to be outside the tornado danger zone. The map in their heads, the one that puts the danger in Oklahoma, the one that decades of national media and popular culture have reinforced, has not been updated. When the wireless emergency alert arrives at 1:45 in the morning, some of them will shelter appropriately. Some will not wake up. Some will open the door to look at the sky and see nothing but rain and hear nothing but thunder and wait. On this interpretation, the 21st century's most catastrophic American tornado, disasters are not in the history books. They are still coming. What changes that trajectory is not a single policy decision, but a wholesale reimagining of how the United States thinks about tornado risk. Where it lives, who is in its path, and what the obligation of government and private industry is to the people who cannot afford to live anywhere else. What data would distinguish between these three interpretations? The continued annual SPC tornado climatology data, which will tell us whether 2025 was a step change or an outlier. The Vortex SE final findings, which will characterize the Deep South tornado environment with the resolution needed for operational warning improvement. NWS staffing, trajectories, and their measured effect on warning lead times in future Deep South events. Manufactured home anchoring compliance rates following any enforcement actions. And whether the dry line position, as measured by the Seeger methodology, continues its documented eastward trend through the late 2020s. Victor Gensini has been watching those metrics for 7 years. He has stated consistently that the trend is still there, and the evidence continues to accumulate. The data will determine which of these interpretations the next decade confirms. Strip everything away. The cases, the case studies, the historical comparisons, the policy arguments. Strip it to the verified core, because the most important thing this investigation can do is be honest about exactly where the certainty ends and the uncertainty begins. What is confirmed by peer-reviewed multi-study evidence, tornado activity has shifted measurably eastward since 1979. The Gensini-Brooks study tracked it using two independent methodologies over 38 years of data and found significant increasing trends in Mississippi, Alabama, Arkansas, Missouri, Illinois, Indiana, Tennessee, and Kentucky. The trend has continued to accumulate in the years since the study published. Victor Gensini, as of 2025, continues to describe it as ongoing. The dry line, the primary atmospheric boundary governing storm initiation, has shifted approximately 140 miles eastward since the late 1800s. This is confirmed by the Columbia University research published in Earth Interactions, and it is consistent with theoretical projections for a warming atmosphere. The combination of increasing tornado risk and increasing vulnerable population in the Mid-South has produced a threefold increase in Mid-South housing exposure since 1980. This is the 2024 finding from Strader, Gensini, and Ashley in NPJ Natural Hazards, and it was produced using 40 years of finite-scale demographic and meteorological data. Manufactured homes represent 6% of U.S. housing stock and accounted for 54% of housing-related tornado deaths from 1985 to 2017. Residents of manufactured homes are 15 to 20 times more likely to die in a tornado than residents of permanent structures. This is established in multiple studies and confirmed by the National Weather Service's own data. The Southeast has the highest manufactured housing density in the United States. Basements are rare throughout the region for documented geological and construction reasons. Community storm shelter coverage is insufficient relative to the population at risk. Tennessee leads the nation with over 73% of tornado deaths occurring at night. The Deep South has a significantly higher proportion of nighttime tornado deaths than the Plains, driven by Gulf-sourced overnight instability. The March 2025 tornado outbreak was the largest in recorded March history, producing 118 confirmed tornadoes with an outbreak intensity score of 147, historic classification, causing $11 billion in damage, the highest for any single tornado outbreak in U.S. history unadjusted for inflation. At least 4 NWS forecast offices, including the Jackson, Kentucky office, responsible for warning the area most severely struck in May 2025, were operating without permanent overnight forecasters at the time of the deadly May 16th-17th event, a direct consequence of staffing reductions. What is scientifically uncertain and actively debated whether the tornado shift is primarily caused by anthropogenic climate change, natural decadal variability, or a combination. Gensini has been consistent in saying the pattern looks like what climate change would produce, while also being consistent in saying he cannot confirm causation with current data. The research community is working to establish this distinction, and it matters for projecting future trends. The magnitude and pace of the dry line's continued eastward shift under various emission scenarios. The Columbia University projections show continued movement, but the precise timing and extent depend on atmospheric dynamics that remain areas of active research. Whether detection improvements, more spotters, more population, more sophisticated reporting tools account for a significant portion of the apparent increase in Southeast tornado reports, beyond what the STP analysis already controls for. The long-term trajectory of NWS staffing and operational capacity. As of mid-2025, the agency was actively seeking to fill critical vacancies, and some offices had begun rebuilding. Whether this produces a sustainable recovery or represents a temporary stabilization before further reductions is not knowable from current data. What remains unknown, the full findings of the Vortex SE campaign, which has been running field operations since 2016 and has accumulated data on Deep South tornado environments at resolutions previously unavailable. These findings will be important for both operational forecasting and scientific understanding of why the Southeast tornado environment differs from the Plains. The actual manufactured home anchoring compliance rate across Deep South states, the gap between what federal and state regulations require and what installation inspection actually confirms. Ruesch's Lee County analysis documented what failure looks like in a specific event. Systematic compliance data across the full manufactured housing inventory in the region does not exist in published form. Whether the 2025 season represents a step change in the trend, a permanent ratcheting up of baseline outbreak frequency and severity, or an extreme outlier that will be followed by a return to more moderate activity. Closing the primary loop, is the Deep South prepared for what the science has confirmed is coming? The answer, by the documented evidence, is not adequately. The warning system functions, and when it functions well, under surge conditions and with experienced forecasters, it saves lives. The housing stock in the path of the emerging tornado corridor is structurally unsuited to the threat by a factor of 15 to 20 times relative to permanent construction. The shelter infrastructure does not reach the populations most at risk. The public mental model of tornado risk in the United States lags the current scientific evidence by at least a decade, and the warning infrastructure is operating under staffing and data collection strain at precisely the historical moment when the storms are increasingly concentrating in new territory. None of this means that catastrophe is inevitable. The Warn on Forecast project represents genuine, important progress. The research community is doing the work. The Vortex SE data will eventually produce actionable improvements in warning specificity for Deep South events. Emergency management professionals in Alabama, Mississippi, Arkansas, and Tennessee know their community's vulnerabilities with a granularity that no national policy document captures. But the gap between where the science is and where the policy response is remains wide, and the storms don't wait for the gap to close. There is something this investigation cannot give you. It cannot give you the certainty that the policy decisions will be made, that the shelters will be built, that the anchor systems will be enforced, that the public education will reach the families who need it before the next outbreak. Those outcomes depend on choices, institutional, political, individual, that haven't been made yet. What the investigation can give you is the record of what is known, that the tornado corridor has been moving east for at least 46 years of documented atmospheric data, that the region it is moving into is more populated, more vulnerable in its housing stock, more forested, more nocturnal in its severe weather, and less culturally prepared than the region it is leaving, that the families in its path are not abstractions. They are the people in McNairy County, Tennessee, who buried 9 neighbors in 2023 and 5 more in 2025. The people in Pulaski County, Kentucky, who received the life-threatening situation alert at 11 p.m. on May 16th and made whatever decision they were able to make in the time available. The people in rural Mississippi who heard the rain on their roof and could not tell from any visual evidence whether there was a tornado in that rain. Victor Cincini, as of 2025, continues to monitor the trend data. He has been doing this for 7 years since the 2018 study. Each year adds a data point. Each year, by his own accounting, the evidence for the continuation of the eastward shift accumulates. He has not published a retraction. He has not said the trend reversed. He has said, consistently, that it is still there and it is still growing. The 2026 season is underway. Through late April 2026, 297 tornadoes have been confirmed across the United States. The states leading the count include Illinois, Indiana, Michigan, and Arkansas, not Texas and Oklahoma alone. Illinois and Arkansas and Indiana. The Vortex SE findings, when fully published, will be the most important scientific document produced on Deep South tornado meteorology in a generation. This investigation will be watching for them. When they come, we will be here. The manufactured home anchoring enforcement data, if a systematic compliance survey is ever conducted across the Southeast states, will tell us whether the decades of regulations have produced the safety improvements they were designed to produce, or whether the gap between what the law requires and what the installation inspection confirmed is as wide as the disaster record suggests. We will be watching for that too. And when the next major outbreak comes, because the atmospheric data says there will be one, and the trend says it is increasingly likely to be centered in the Deep South, this investigation will be examining where it went, what the warning lead times were, what the structures were, what the shelter options were, and whether anything changed between the last outbreak and this one. This community is why that watching is possible. The people who understand that the most important weather story in America right now is not the one the cameras follow to the Oklahoma plains every spring, but the one unfolding quietly in the forests and valleys and mobile home communities of the Deep South, where the storms are increasingly going and the preparation is not keeping pace. You are that community. You have been with this investigation from the beginning. We don't know yet which of the three interpretations this evidence will ultimately confirm. We don't know whether the policy response will meet the scale of the problem before the problem produces the kind of catastrophic event that makes the gap undeniable. We don't know whether the trend lines will continue, accelerate, or stabilize. But we know the evidence. We know where it points. And we know that the families in the path of these storms deserve to have that evidence stated plainly, publicly, and without panic, measured, documented, and honest about what is certain and what is not. The investigation continues. We will be watching. We will be here.